Great. Hey, it's fun to be here. Thank you, Domino, for the invitation. I am a scientist by training. I have a PhD in ecology, a master's in conservation biology, an undergrad in biology. But now I am the interim chief scientist for a large nonprofit that's been around for over 100 years, the National Audubon Society. We're focused on bird conservation across the United States and across the Americas. And it may sound a little bit different that I'm here up here talking to you, but the reality is that just this entire conversation that we just had around the Center of Excellence and data science in general is absolutely what we're doing at Audubon, and using data science to inform our conservation work. And so I want to just tell the story of how data science has evolved over the last 5 years within Audubon. And I feel like just based on what we heard, you're going to see a lot of parallels with your own organizations. And I just want to share some of the lessons that we've learned, as well as to share a little bit of some results of some analyses that we've done around birds and conservation. So an opportunity to see a little bit different application of data science to what you're used to. So obviously we're a bird conservation organization, and we tell our stories about data using birds as the lens. Birds are beautiful, inspiring. A lot of people are very passionate about them. And so what we try to do is to tell stories about birds and how they maybe are indicators of what's going on in our world and the problems that we need to solve from a conservation standpoint. At Audubon, we have been, our organization's history is one that's founded on science and data in particular. One of the activities that's been going on at Audubon the longest is something called the Christmas bird count, which is an activity that was started in 1900. People who were around in 1900, they used to go out hunting birds on Christmas Day. That was a popular activity. And so some new conservationists at that time period said, why not go outside and count the birds instead of hunting them? And so they started in a couple of places, including San Francisco, this activity on Christmas Day to go out and count birds. And that activity has grown. Today, it's been going on now for this year, we have our 120th count. And we have 75,000 people who are participating in these annual counts, going out and observing birds, counting them, and then recording their data and inputting it into a system that then comes to us and is available for us to do analysis and data science with. And so that's an over 100-year tradition around collecting data and engaging the public. In this conversation, we're talking about building organizations, for-profit companies that are data-driven, that might have a data science center of excellence, that are focused on key performance indicators to drive business and profits ultimately. At Audubon, we just have a little bit different way of thinking about it, but it's the same. It's not different fundamentally. We try to build an organization, a conservation organization that's science-based. We want to be making policy recommendations, advocacy, and doing on-the-ground conservation in places that have been identified by science as being important, policies that are useful based on science. We've talked about a center of excellence, actually. I was really excited to hear this overview, and it was very useful. We have a science division, which serves a lot of the same elements that you were describing, and I would say we're kind of midstream in doing all the things that you laid out as being sort of the key components of a center of excellence. And then instead of key performance indicators, we talk about habitat. How much habitat have we protected? How many birds have we saved? And one of the things that we're striving to do is to really be able to demonstrate that, to show with hard data that we're actually having an impact with our work. And again, it's not that different from a for-profit enterprise. So birds, again, are magical and inspiring. This is an eared grebe, a species that you can see around the San Francisco Bay. It's a migratory species that moves between kind of Intermountain West down into Mexico every year. So it breeds in the Intermountain West and then travels down to Mexico later in the year. What we're having in sort of the science world is a explosion of information, explosion of data, the same thing that's going on in technology, right? The same thing that's going on in business. We have a lot more data to work with than we had even 10 years ago. And so, we're going from having, just a little bit of information about one place, one species, a few data points, to having an overwhelming amount of information as more people are going out. We have a phenomenon called citizen science, where people are going out and collecting data using their smartphones. They're inputting observations of where they see birds. It's geo-referenced. It's a data point that we can then use in our scientific analyses. And so these types of activities are, and I include within that the Christmas bird count that I mentioned before, are really creating a real opportunity for us to do more sophisticated data science. And this new type of data that is coming in from all these different sources is a little bit more messy. And so it doesn't necessarily fit into traditional statistical frameworks. And that's why we're moving toward machine learning and applying some of the tools that we associate with data science, because they're able to work with non-structured data in a more effective way and make good predictions. And so really we are within Audubon, a conservation organization, applying the same tools that you might be applying in a business context, only we're applying it to birds and trying to inform our conservation work. And so as I've kind of already mentioned, there's all these platforms that are now available for collecting data on bird observations and the environment in general. We have our Christmas bird count. There's something called eBird, an app that you can download on your phone and record your observations of bird anywhere that you are. iNaturalist is a platform that's actually sponsored by the Cal Academy of Science, if you've ever been over there. And that's for not only observing birds, but observing plants, observing mammals, anything that you want to see in nature. You can create a data point and record your observation. Companies like Esri have tools for collecting data in the field. There are organizations such as MoveBank that allow us to track information on how animals and birds are moving through the environment. And so we're moving from data, we still have data deficiency in a lot of areas, but we are moving towards an area, a world where we have a lot more opportunity to tell stories with data. This is a visualization that we created for our friend the eared grebe, where we're actually moving through the annual cycle of the species, and we can see where the species is throughout the year. It's moving across the landscape, and we're combining here different data sets all in one visualization. And so the stipples, which are very hard to see on the screen, here's some down here during the winter, is eared grebe on its wintering grounds. That's eBird. That's just random people going out and observing the bird in its natural environment. Anyone can do that and enter that data point on their smartphone. So there we can see that data type. We also are seeing here these more larger dots that are then moving across the landscape. Those are basically based on either tracking devices that are placed on the bird and maybe are transmitting to a satellite, and we can see where the bird is moving using a satellite georeference point, or it's based on bands. The birds have been banded, and then that band is recovered. So it might be banded in San Francisco Bay and then recovered in the Great Salt Lake, and that creates two data points that we can connect to know that that bird had been in both places. And so again, this is just a lot of opportunity here to look at different data sets and combine them to tell stories about birds and to identify the places that are most important for their conservation. This is just another example. Here we have a little bit more data. 153 individuals of golden eagles, a very majestic species that is clearly making use of this corridor of mountains, the Rocky Mountains moving up into Canada and Alaska to do their migration between their wintering grounds and their breeding grounds up in Alaska. And so for us as an organization, we're trying to use this information to inform our conservation and make smart policy, advocacy recommendations, and to protect the most important places for birds. Within our science division, we really focused in on kind of three types of data science. We do a lot of predictive modeling, and the example that I'm going to share with you of how we applied Domino Data Labs platform is predictive modeling. The predictive modeling is often trying to define a problem, a future threat that's impacting birds. How can we anticipate those threats and try to get policies in place that are going to be successful at mitigating them? We also try to measure our success as a conservation organization, looking primarily at trends in birds. So this is a map. Again, just the colors aren't showing. This is actually North America. Can't see the white outlines here, but this is the Southwest, and we can see where wintering bird populations have been declining in red and increasing in blue. And so these are statistical analyses that are based, again, on the Christmas bird count, that community science activity that I described at the beginning. And then finally, we do a lot of spatial optimization, where we're looking across data and trying to find the optimal places to do conservation work. And so that's another type of modeling that we do. So these are the three types of analyses that we really focus on within our science division. So how has data science transformed the organization? When I started at Audubon about 6 years ago, our data science group, which I refer to and we refer to as our science division, was really isolated. we were a few of us sitting here in San Francisco, and we kind of kept our heads down and did some interesting scientific analyses. And then when we were done, we stood up and said, hey, look at this. And we hoped that someone cared, and sometimes they didn't. And it was kind of a real isolated process. And even some of the conversations that I've had already this afternoon suggested that that is not, exclusive to a nonprofit, right? I mean, you have data science groups that are trying to do analysis and say, hey, this is important, this can help, but you don't necessarily have someone listening or appreciating the value. And so what actually my job was to do was to take our data science group, our science division, and make it more integrated into the organization, and that required alignment. And so our organization has a strategic plan, it has priorities. Maybe we could look at these as business divisions to try to broaden the context here a little bit, but we aligned our work so that we were doing something for each of these groups. And it took a lot of time to understand what their priorities were and then to incorporate that into what we were working on, so that there was a clear connection between the organizational priorities and what we were working on a day-to-day basis. And in particular, so that leadership knew what we were doing. Before, they were just like, oh, we have a science division, but we don't really know what they do. Now they actually can relay and actually communicate some of the things that we're working on, and they can see that connection between what they've identified as our organizational goals and what we're working on. And so that was a critical first step. To do that effectively, it was about culture and communication primarily. We really thought hard about this. When we first started to try to integrate with different groups across the organization, we got a lot of resistance, and people were very threatened by this new entity trying to step in. And so we really had to create a set of core values and kind of a way of approaching this to maximize our success. And so we focused in on our own motto of coming in and trying to do data science that was going to add value, not replace. That was a really important component. A lot of people were really proud about what they've been doing. It's a 100-year organization. There's a lot of great work that's been going on. So we needed to be complementary to what was already happening and add value. And then we had to have kind of these core values of high quality work, but then also, and this is all about attitude, having humility, really beginning conversations by listening first, and having a little bit of empathy and patience when you're having those initial conversations to understand where people are at and to make sure that they are, seeing that you're here to partner. You're not here to take over. You're not here to step on or to show what they're doing wrong. That was a big fear as well. You're here to partner with them and to help move things forward. And so those ideas were really important at the beginning. And then finally, for our staff, having a growth mindset, which already came up earlier, of really trying to think about, okay, we might not be able to do everything that's needed right now, but we can grow, we can learn, we can apply new skills, we can learn new skills and make them tailored to what you're doing. And that not only is exciting for the partners, but for the staff as well. Everyone who works for us wants to be able to grow in their position and learn new things. And so we've actually have really high retention. And I believe that the growth mindset and giving people opportunities to learn and grow in their positions has really been a key to that success. And then finally, just building on success. So initially, we had a small group. It was just me. I was actually the first person who was doing a project with one of our state offices. No one had been doing that before. And so that project was successful, and it was built on strong relationships. And then that began to have kind of an echo chamber effect. So if you have a leader in a division that you're working with talking about how great this was to partner with you, and then they're sharing that with other leaders, then somebody else might say, oh, we want that too. And so it really starts to snowball, and you get a lot of growth as a result of those early successes. And so that was definitely a key for us. And actually, from a science division perspective, we've grown from, at one point, we were as few as 2 analysts. Now we're up to 16 people who are all doing data science and applying it across the organization. So again, we're a 700 person nonprofit, a different context than a for-profit business, but this is still reasonable growth in a relatively short period of time, and it's accompanied an integration throughout the organization. And so it reflects not only growth in the team, but growth in the organization and maturity in the way that data science is viewed across the organization. All right, so that's the case study for Audubon, and hopefully you find that useful just to hear our story and how data science has evolved over time. Now I'm just going to pull your ear a little bit and just show some of the work that we've done. I recognize that this is completely outside of your sphere, but hopefully you find it a little bit interesting. We're not necessarily trying to do science to improve our business or to make higher profits or some of the things that might be relevant in other contexts. We're doing science to try to inform conservation. And so what I want to tell is a little bit of a story here about climate change and what it might mean for birds. This builds upon work that's been done at an international level. The Intergovernmental Panel on Climate Change is an international body that tries to think about what climate change might mean for the planet. Just recently, or late last year, they came out with a report saying that we really already have 1 degree Celsius of average global warming across the planet. In some places it's greater, in some places it's less. And we're on a trajectory that's going to almost certainly eclipse 1.5 degrees of warming. And currently we're on a path that is going to eclipse 3 degrees Celsius of warming. And unless we take dramatic action to reduce greenhouse gas emissions. And so at Audubon, we're really interested in this topic, and we wanted to understand what it meant for birds. And the way that we did that was to model, using machine learning models, where is there suitable habitat and climate for each bird species. We did this for 604 different species of birds. This is work that we did on Domino's platform. And this is an example of kind of the outputs where we can see here the current range of the species is in red, orange, and yellow. And this is predicting to the future. We can see in red places that are no longer going to be suitable for the bird. Orange are places that are worsening. Light blue are places that are improving where we see the bird today. And dark blue are places where the bird may be found in the future. We built these models, and that was the American robin, sorry. We built these models using a workflow, again, that we deployed in Domino. We built a database of information that included both bird observations and environmental covariates, so things like climate and habitat. We then queried that database and extracted a table of observations and covariates. We then tried a numerous set of data partitioning and filtering methods and built a whole suite of models, and then had several performance criteria that we evaluated those models with and selected a top model and then predicted into the future how those ranges would shift using these projections of future climate at the middle and end of the century under different warming scenarios. And so in particular, and then we use that information to characterize for each species how vulnerable it was to climate change. Is it going to be really impacted, or is it maybe going to do okay? And to do that, we looked primarily at how much of its range would it likely gain or would expand, and how much of its range would be lost under a changing climate. We were able to combine those together to think about overall vulnerability. You can think about vulnerability as how much of the current range is going to be lost. If it's going to lose a lot of its current range, it's highly sensitive. And then how much potential does it have to gain? Is it able to adapt and expand into new areas? This is the range that it could gain. If it's able to move into new areas, maybe it can adapt to climate change. And so the most vulnerable species are species in red that are going to lose a lot of their current range and are not able to expand into new places. We did this, like I mentioned, using Domino's platform. We did this for 604 total species for 2 different seasons, winter and summer. We built 160 machine learning models for each species, in total over 180,000 models. And Domino was really helpful in allowing us to scale up this work as well, or actually I think that's my next slide. There are 4 data scientists collaborating on this work. And Domino helped us scale this up. Initially, we did this for only grassland species, which was 40 species, and we scaled it up to 604. And it was really important to go back to one of the points that was made earlier. You certainly could kind of plug and play this type of work, like every species treated the same and just go, and it creates all these models, and then you look at your outputs. But what we wanted to do, and what Domino's platform allowed us to do, was to have an expert scientist go in and look at every single model and tweak some of the parameters, explore different parameter sets, and make sure that we had the best model for each species. And it was the platform that allowed us to do that and to collaborate across that team to do that as effectively as possible. So here's just some results for grassland birds. Nearly 1/2 or 42% of grassland bird species, there's about 39 species, are highly vulnerable to climate change under a 3-degree warming scenario, which is kind of the trajectory we're on right now. But if we're able to change our policies and reduce our greenhouse gas emissions and have less warming, we could see that number of vulnerability decrease to 1 in 12 species. So as a conservation organization, this is a really important message for us, that this isn't like a foregone conclusion, that we could actually take action to reduce our emissions and have a world where fewer birds, we're using birds as our lens, but of course people are in here too, for fewer birds and people are going to be vulnerable to climate change and its impacts. Some of these impacts are quite dramatic. Here's just a projection for one grassland bird species, Baird sparrow, where we can see how in light green here, this is the proportion, this is the area of its current range that is no longer suitable in the future. And so quite a bit of its range is kind of no longer suitable. And under the 3-degree scenario, there's basically no suitable climate or habitat in the future. And so some of these predictions are quite dire. We also looked at, as I've mentioned, 604 species. These are some results that are going to come out next month. And so I'm actually not able to show you the exact numbers here, but I did just want to give you a taste. We looked across not just grassland birds. This is the numbers that I just showed, but there are other groups of birds, Arctic birds, boreal birds, forest birds in the West, water birds that are even more vulnerable. The number of species that are impacted by climate change is even greater. And so, there's a range of vulnerabilities across groups. And then this is just looking at species that are vulnerable in red and orange versus whether they're not already considered a species at risk. And so if you live in California, maybe you've heard about the greater sage grouse or the tricolored blackbird. These are 2 species that are at risk in California or portions of California, and they are also highly vulnerable to climate change. So this is going to be something else that they're going to have to deal with. In addition. And then there's also species that are really not on anybody's radar for conservation right now that are highly vulnerable to climate change. What are we going to do about all those species if we continue to have warming at the pace that we see today? We also looked at, in addition to kind of these large-scale vulnerability, we looked at some very specific impacts of climate change: sea level rise, extreme heat, drought, fire, heavy rain, and we have some analyses that look at where we're going to see multiple impacts. We can map those out and how that changes depending on the degrees of warming that you see. Obviously, the more warming we have, the more places are going to be impacted by multiple compounding things. So as I mentioned, we have a report that's going to be coming out next month. If you're interested in anything I've shared with you today, I hope you'll go to the Audubon website and check it out. And then the grassland results that I shared are part of a report that came out in July. So that's already out, the North American Grasslands and Birds Report. And you can also Google that and see that online, where we've done, again, assessing vulnerability of birds to climate change using Domino's platform, as well as doing some of that spatial optimization that I mentioned and mapping out the most important places for conservation of grassland birds. So just in closing, I just wanted to say that, it's been a great opportunity to show some of the things that have worked, but we're still struggling as well, as everyone is, I imagine. And they asked me to talk about kind of my needs and challenges advancing data science. I think the biggest need right now is investing in infrastructure. We have a lot of data on CSVs all over the place, so common theme. And we've been talking about a data warehouse. And so that's something that we're kind of excited about and have been trying to explore with different consulting groups. And yeah, it's a challenging and potentially expensive proposition. And so we're trying to explore that, but I think that would allow us to take this to the next level of being more efficient in how we're deploying our data science capacity, instead of maybe being a little bit more one-off, which is kind of maybe where we're at right now. And then one area that we really haven't gotten into at all, and I think this is probably more relevant in a business context, but I'm excited to try to explore whether it would work within our context, is more on-the-fly deployment of models. So a lot of the stuff that we're doing now is kind of building a bunch of models, creating some outputs and sort of using them to inform our work, but can we create systems that are like ingesting data and creating an output in real time that's then useful? And that's, I think, on the horizon for us. And of course, Domino is a platform that would allow us to do that. We just haven't quite made that leap yet. So hopefully, I recognize it's a different field, but I feel like just listening to earlier conversations and talking with folks in the room that there's certainly parallels. And this is our story. And I'm looking forward to the rest of the afternoon to just share with you guys and hear how data science is going for you and hopefully learn from you as well. So thanks a lot for your attention.
Does anyone have questions?
Full disclosure, I use eBird. I love it. Curious, of those sources that you're pulling data from, have you seen some mature faster, some really useful, some that you don't use anymore? I'd love to know how you view those data sources.
So, I mean, really we're drawing from, so we draw from eBird, we draw from federal data repositories. The USGS has a number of data sets that we use. There are some international data repositories. One of them is called GBIF, which is the Global Biodiversity Inventory something with an F. What we're seeing, honestly, is an eclipsing. eBird is eclipsing all other sources. It's the coverage and the data density is increasing exponentially, and it's still not the biggest data set that we. Let's see, it's tied right now for the biggest data set that we use, but it will quickly be, without a doubt, the biggest data set that we use. And I think what it lacks is that longitudinal depth, so it doesn't go back as far. So it's limited in that sense, but it is, yeah, it's just got a lot of points, basically. So, yeah. Great. Well, hey, thanks again.
Thank you, Chad.